Let's do some application problems that involve the first derivative and graphs. So increase, decrease, local extrema, critical numbers. So the graph shows the approximate rate of change of the price of eggs over a 70-month period, where E of t is the price of a dozen eggs in dollars and t is the time in months. Determine when the price of eggs was rising or falling and sketch a possible graph of E of t. So it's important to notice here that this is the rate graph, not E of t. So to do one more time what we talked about in the last video about first derivative and graphs, here everything up here is positive and everything down here is negative. And then this is where f prime of x is equal to 0. So let's take a look at the intervals that are negative and let's take a look at the intervals that are positive. So from 0 to 10 months, I'm below the x-axis, so I am negative. F prime of x is negative, I should say. From 10 to 50, I am above, so I am positive. And from 50 to 70, I'm below, so I am negative. That means that for f of x, this will decrease, this will increase, and this will decrease. Now, anywhere where f prime of x is equal to 0, that is a critical number. So let's take a look if it's a max or a min or neither. So I have two places where it's 0. I have that f prime of x is equal to 0 at x is equal to 10 and x is equal to 50. So if I do my little chart here with the information from above, I am decreasing from 0 to 50, increasing from 10 to 50, and decreasing from 50 to 70. So that means that 10, if I'm decreasing the increase, is a min, and 50 is a max. So determine when the price of eggs was rising or falling. So it was rising from 10 to 50. So increasing means that this is when it was rising, the price was rising, and it was decreasing, that means the price was falling in terms of the context of our question. And sketch a possible graph. So we'll go here. We'll do a small graph. Now we don't know how much the minimum was or the maximum was, right? So it's a sketch, but we should put our important numbers, 10, 50, and 70. So this is 10, this is 50, and this is 70. But keep in mind that price can never be negative. That doesn't make sense. So f of x can never be negative, okay? It's a price. So say we started somewhere here. We went down to 10, we hit a minimum, we increased to 50, we hit a maximum, and then we decrease back to 70. Okay, so this would be a possible sketch of our graph. So here I am decreasing, here I am increasing, here I am decreasing. This is a min, and this is a max. And this is a possible E of t. Okay, let's look at another one. The graph of the total revenue R of x in dollars from the sale of X desks is shown below. Write a brief description of the graph of the marginal revenue function y is equal to r prime, included in discussion of any x-intercepts. Okay, so now this is the opposite. Now it gives us r and it wants the derivative. The other one is it gave you the derivative. So let's take a look here at, now we want to take a look at where it's increase, decrease, and where it's hitting any maximums or minimums. So they even draw the horizontal tangent line for you, so you see exactly where the derivative is going to be 0, because the derivative is 0 when it hits a max or a min, or neither, but here it's definitely a horizontal tangent line. So let's take a look. Where is it increasing? Where the graph is increasing from 0 to 450. It is decreasing from 450 to 1000. And at x is equal to 450, we have a max. So when you have a maximum, that means that f prime of x, I'm sorry, I should use r because we're talking about revenue, r prime of x is equal to 0. So this will be an x-intercept of our marginal revenue function. So write a brief description of the graph for the marginal revenue function. What we're going to have is anytime it's increasing, so right here, r prime of x is going to be greater than 0. Anytime it's decreasing, r prime of x will be less than 0. And at 450, it will be an x-intercept. So let's take a look at a possible graph. So first I'm going to plot the x-intercept. It's going to be right here, 450. The graph goes up to 1000, so I don't want to stop. So increasing means greater than 0. That's above the x-axis. So I'm going to start somewhere right here. I'm going to 450, right? Because this is positive above x-axis. And then I'm going to go down somewhere to 1000. I don't know where exactly, right? It's just a sketch. But here, this is negative, which is below the x-axis. And this is an x-intercept, right? This is r prime of x is equal to 0. And here's a possible sketch of your graph. Let's do one more. The concentration C of T in milligrams per cubic centimeters of a particular drug in a patient's bloodstream is given by the following function, where T is from 0 to 12 and T is the number of hours after the drug is taken orally. Find the intervals on which the drug concentration is increasing, decreasing, and the local extrema. So it doesn't ask for a graph, it just wants you to find the intervals and any max and mins. So to do that, we need to find the derivative. And to find the derivative of this, we need the quotient rule. So my t will be 0.3t, which means that t prime is going to be equal to 0.3, and that's it. Then I have b is equal to t squared plus 6t plus 9, which means that the derivative of b will be 2t plus 6. Okay, so c prime of t will be t prime b minus tb prime all over b squared. So c prime of t, let's plug in all the goodies, 0.3 times t squared plus 6t plus 9 minus 0.3t times 2t plus 6, and that's going to be all over t squared plus 6t plus 9 squared. So let's clean up the top. So I'm going to distribute the 0.3. So 0.3t squared plus 1.8t plus 2.7. And then I'm going to distribute a negative 0.3t. So that's going to give me 0.6t squared minus 1.8t. And before I write the bottom, I'm just going to clean this up because I see some things cancel. I have a positive 1.8 and a negative 1.8. And I can combine this and this because they're like terms. So that's going to give me a negative 0.3t squared plus 2.7 all over t squared plus 6t plus 9 squared. Okay, so here's my derivative. Now I can notice actually that the bottom factors also. Because remember that when I'm taking a look at increase and decrease, I need to take a look at where my derivative is 0 and where my derivative is undefined. So let's take a look at 0 first. So if I set this equal to 0, I will bring this here. I will get negative 0.3t squared plus 2.7 is equal to 0. I will bring the 2.7 over. I get 0.3t squared is equal to negative 2.7. I divide by negative 0.3. That will give me that t squared is equal to 9, which means that t is equal to plus or minus 3. But remember that t was time and it was only between 0 to 12. So the negative is out, right? I'm not in my interval, so I only have t is equal to 3. That's when my derivative is 0. Now I need to look where it's undefined, and it will be undefined when the denominator is 0. So I get t squared plus 6t plus 9 squared is equal to 0. I square root both sides. I get t squared plus 6t plus 9 is still equal to 0. This factors nicely for us as t plus 3 squared is equal to 0, which means that t is equal to negative 3, which we already know is not part of the interval. Okay, so that wouldn't work. So we only have one partition number, which is actually a critical number because it's when it's 0. So we draw our interval, and be careful, it doesn't go from negative infinity to infinity. It starts at 0, 3, and then it stops at 12. So I just need to check in between these two. So here I'll pick 1, and here I'll pick 4. This is my x, and here I'm plugging it into my, well, I should say t, I'm sorry, not x. And here I'm plugging it into my c prime of t. And then you're plugging that into the derivative, right? So I'll circle the derivative one more time. Here was our derivative. So I have c prime of 1. That's going to give me negative 0.3 times 1 squared plus 2.7. Well, that's definitely going to be a positive number in the numerator, divided by, and then I'm going to have 1 plus 6 plus 9 squared. But actually, no matter what's in the bottom, because it's being squared, it's going to be positive. So this is also going to be positive. When you do c prime of 4, you're going to have negative 0.3 times 16 plus 2.7, which is actually going to become a negative number. And again, the bottom is always going to be positive because it's being squared. So here, this is going to be negative. Okay, so if you take a look at what the question was asking again, it said find the intervals on which the drug concentration is increasing and decreasing and the local extrema. So the drug concentration is increasing from 0 to 3 hours, and it is decreasing from 3 to 12 hours. And then one more thing it asked for was the local extrema. So because it's increasing from 0 to 3 hours and decreasing from 3 to 12 hours, that means that it increased and then it decreased, which means that xt is equal to 3 was a maximum. So this is when the drug concentration was at its highest at 3 hours, and then it started decreasing.